Welcome back, everybody. Just going to be awkward for a second. Bet, bros. Cool. Trending down south, 6-7 on the way out. Just so you know, 21 is taking its place again. 21 is back in the rotation, apparently down south, in this guy's videos that I follow, and he talks about it. He takes track of them all the time. Now they're like 7th graders, so keep that with a grain of salt. One of my very least favorite word is trending back. I do not like glaze. I don't like it. Do not like that one.
You're glazing it.
Yep, don't like it. Not a fan. Okay, it means like obnoxiously celebrating them, right? Is what it's.
Yeah.
Okay. What's the other one that's coming back? Chungus.
Oh,
Chungus is coming back. The Chungus revival might have begun. So, in Chungus we trust, I guess. All right, let's check it out. We're going to approach this without doing long division. And we're going to start by key features. Now, for this, there's only 7 of us here today, 8 with me, which means I can call on all of you guys over and over and over and over and over. What's one of my key features I care about? If I want to be able to say how far this thing has moved left, right, up, and down, and to graph it, what do I need? Give me one of the 3 things. So I need to factor it if I can. Let's check. Can you factor this numerator?
X times X.
So you could factor it as x times x, but not really.
You can just leave it like that.
Okay, how about the denominator? So we're always going to try rewriting it, right?
2 plus 2.
Ooh, a 2 comes out, and maybe we'll take, I'm going to do some scratch work over here just so it doesn't get all muddled together. And I'm only looking at the denominator right now. You guys said factor a 2 out of it. X squared minus 1 is left inside. Can I rewrite that any further?
Yeah.
I can. Let's run through our list. We already did GCF, right?
Yeah.
And then now it's a what? It's a difference of squares. And Dex, just because I don't know if you were just automatically saying no or if you weren't quite sure, but I'm going to pick on you for a second. Do you know the square root of x squared?
X.
So check this out. 2, and then remember our shortcut for difference of squares. X minus, what's the square root of 1? 1. And what's the other factor that we get for free? X plus 1. Love it. So right now, all we've done is rewrite it just a little bit, which we need to do anyway. This becomes x squared over 2 times x minus 1 and x plus 1. Awesome. Now that we have the original and the factored version, the rest of this is a cakewalk. It is so much easier to do this than do the division and try to do everything. Let's find it. 3 key features that I care about. There might be more than 3 total, but 3 main things. What's one of them, Wenzel? Do you recall? The roots. Love it. I'm going to put that one on the bottom. What makes a fraction, which this is a rational expression, it's 0 when which part is 0? So the roots, the x-intercepts, it's when this whole thing has a value of 0, right? Because it's when...
Yeah, we can say
So what do I make 0, though? The top or the bottom? Can't do both. If it's 0 on the bottom, I'm dividing by 0.
The roots, right? Or the exponents.
Try again. Other one. We can't have the denominator 0. That would give us... That'd break it. The numerator. So I'm going to do this scratch work in yellow. What's our numerator?
X squared.
And I want to set it equal to 0. What do I get?
0.
So this is a weird one. I'm going to show way more work. You guys, I agree with you. If I went all the way through, do you agree I'd take the square root of both sides? And what always goes in front of a square root when I take it? It's a weird symbol. It's not a number. Okay. Do you guys, and this is going to feel silly for a second, but do you agree it's plus or minus 0? And you may be thinking like, well, that's stupid. Why would I ever write that? But there is a reason. How many times did 0 show up just now? Twice. It was 0 and 0, right? Because even if we think about it as this as being x times x is 0, do you agree that we could say the roots are really at x equals 0 and 0? Follow-up question that it's been a while. Why on earth would I ever write it twice?
Because that matters because of the number line step.
Okay, so check it out. We're going to make this a face unintentionally for a second. This showed up twice. Do you remember what we say has a value of 2? A fancy M word.
Bottom. Multiplicity.
There it is, Kian. Multiplicity equals 2. Okay, and maybe Wenzel also, because I think you might have said it first and then shifted away from it. So what? What does it mean that it is an even number of times that it shows up? What's it going to do on the x-axis? It either crosses it or it touches and turns. So which one?
It touches and turns.
It touches the x-axis and turns around. And we'll see this on the graph here in just a second. The alternative language would be to bounce. I don't know. Touch and turn makes more sense to me. So love it. The roots, and we found that it's at x equals 0, and it's going to touch and turn. So it's either going to go down like this and touch it and go back up, or it's going to go up and touch it and turn back down. One of those. What other key features might I want out of this?
X-intercepts?
Is that different than roots?
No, it's the exact same.
So those are the same, but I do want them. I just happen to have them already. Other things, if you look at the last example or any of theirs, we're asked to find 3 things.
Asymptotes.
Asymptotes. Which kind are we going to find first?
The vertical asymptotes.
Sure. Vertical asymptotes. Where do those happen? And I don't even need any scratch work for this because I've already done the factoring.
Zeros of d of x.
I think you're going to be correct with your explanation, but that is a much more specific answer. The zeros of d of x. Now, what is d in this situation? The denominator. Do we already have it factored?
Yeah.
What values of x will ever make my denominator? Which x's would I plug in to make this 0? 1 for this one, because x minus 1 would be 0 when x is 1. What about this one?
1 and negative 1.
1 and negative 1. So I want you to tell me, what am I doing wrong and why am I going to lose points on a quiz?
Because you're not doing y equals.
I would never do y equals
X
here.
equals
Good.
X.
That was felt snarkier than it meant to. Great catch. It wasn't meant to be snarky at all. I don't know why it came out that way. You have to give me the x equals. Like, I'm going to be crazy about it, just so you know. All right. What about the, that was my horizontal asymptotes, just so you know. Thanks, by the way. How do I figure out my horizontal asymptotes?
Short.
Leading coefficient.
You use a degree test, right? And we check. And that's what you're trying to say first, because we are going to use the leading coefficients as well, just so you know, y'all. So you were right on both regards. What about the degrees? Desi, what's the degree up top? 2. Kian, what's the degree downstairs? 2. They're equal. Jade, what do I do if the degrees are equal? What's them?
Divide the leading coefficient.
So let's keep going. What's the leading coefficient of the top?
1.
Over. What's the leading coefficient of the denominator? Boom. We have all this information at our disposal. Now, this problem is unique, and I'm not your book author, so I don't really have to apologize for it being in the wrong section. But I can't really talk about this as a single transformation just from the parent, because some wonky stuff happens. And we're going to dig into that wonky stuff. But let's look at this. Can you tell me, did this thing move left or right or up or down? We'll focus on up and down first. The parent function, where's its normal horizontal asymptote? 1 over x is our parent. Where's the normal horizontal asymptote if you look at the parent function for these? The reciprocal function. 0, and now it's where?
1/2.
So did it go up or down?
Up.
So if all the question is explain the transformations, do you guys agree that that just says up 1/2? This one, I'm just going to put some stuff here because I don't even know how to make sense of what's going on with this, with just transformation. We're going to see why in just a second. So we can't really talk about does it move left or right because kind of both, but we'll look at it. Okay, can we graph with just this info?
How do we find the mystery?
The what? So we don't yet. I know where the asymptotes are, but if it was originally at x equals 0 and now it's at 1 and negative 1, I can't really say it just moved right 1 or left 1, right? That's why I put that here. Like this is a weird one, and we're gonna look at it. It's gonna be a weird one. Okay, let's try to graph this. And the only thing that we might need, we don't have to make big tables unless you guys want to. We can make tables with like hundreds of points, or we can just find a couple points to point us in the right direction. So let's try it. First thing is I'm just going to pick my scale, and we're going to be really, really precise and make sure that any time that we're doing this, if we're going to draw asymptotes, I would encourage always label x and y. Now, just a good practice. My scale is nice because I'm working on graph paper all the time. You guys don't all have graph paper right now. Some of you do, and that's fine. If I only need to be able to show 1/2, do I really have to make that a change of 1? I could pick a bigger scale to see it better, right? I'm going to jump by 2 here. So remember, and we're all rusty from this, but if I don't put any number on it, every tick is implied that it should be how far? So careful, I'm moving 2, but if I don't label it, I'm always going to assume it's 1. I'm doing this so that my graph gets a little bit more zoomed in so we can see it better. If you need to put some stuff on here, I'm making each tick 1, is what I'm doing. I'm just making it so it's more zoomed in. Okay, in the x direction, I have to show my asymptotes, which means I need to at least see 1 and -1. If I do it the same scale, can I see 1 and -1 pretty well? Yeah. Okay, so now we have our scale picked, and we're going to start putting some points on here. Let's check. I need to put my asymptotes on this graph. Now, I am going to try, I'm going to try to do the same as you. I have a bunch of colored pencils if you guys want them to use, just so you know, so if you want to color code stuff. But if you're doing it with just marker or pen or pencil, how do I want you guys to show your asymptotes on your graph? We dash them. So I'm going to draw a horizontal line where? Y equals 1/2. So check it out. Because I picked a little bit bigger scale, I can see it, and I'm going to label my asymptote. Y equals 1/2. Now, I'll keep doing it. Desi, do you already have all this, and this problem went okay for you? Are you, like, did you already have all this same stuff?
Yeah.
Okay, awesome. Okay, any other things I should add on here?
A vertical line.
All right, I'm going to do a vertical line through x equals 1. That's a vertical asymptote. I'm going to do a vertical line through x equals -1, and then I'll dash it.
That's cheating. We can't do that.
I mean, yes, you can. What do you mean you can't do this?
Dash the line. It takes forever.
Does it, though? And I don't know. I feel like I'm just coming at you today. I'm not trying to. I am trying to be snarky, but not just target you. Declan, I respectfully disagree.
What?
Were you drawing the line and erasing it?
Yes.
That's fair. If you guys want to see something crazy, about half you guys have seen it. If you want a short brain break after we learn a new vocab word today, we can go over to the science lab and I'll show you some chalk stuff.
Okay, Ben.
Oh, yes.
Oh, I know that one.
Do you know my chalk trick?
Oh, no, I saw it on TikTok.
I've never had your science class, so. No.
Yeah, and you won't either.
Like how to make a dotted line.
Okay, we have these. I only have 1 point right now that I can put on my graph. What's that point? Only 1 point that I can actually put on here.
The intercepts at 0.
It's at 0, right? This is the only point. This is the only point that I've worked out so far. Now, here's where we're at. This is why we can't say it's just to move left or right. There's some wonkiness that's going on. I have 2 options right now, and we need a way to figure out which one it is. I know that the graph is going to touch and turn here because of this multiplicity deal. Now, there's 2 options, though, and I don't want you to draw these until we decide which one. The first option is it could come like this and turn around like that, right? That's a possibility. The other one is it could do this. And I know it touches the asymptote, but remember the horizontal asymptotes don't care if we cross them in the middle, only towards the ends. I need a way to determine which of those it is. How?
Desmos.
I'm not going to use Desmos, but Desmos could help you with it. All I need to know is
Pick a point.
something in here. Let's pick one and just see if it gives me a positive or a negative.
Pick one.
I can't pick one
Why?
because I'm undefined when x
How
equals
about
1.
0?
0, I already know it's going to give me 0.
Oh, then 2.
2 just tells me that one's going to be out here.
1.
1 is undefined.
Negative 1/2.
1/2.
1/2 will do it. I'm going to pick any point in this range, something between those. And I don't have to go crazy with it. I erased my scratch work, but I'm going to do a little bit more here. If I wanted to find f of 1/2, all I care is it positive or negative? And let's just check. What's 1/2 squared.
One.
That's not true. That's 1/2 times 2. What's 1/2 times 1/2?
1/4.
Okay, so that numerator is 1/4 over, I already know that it's 1/4 for x squared again, right? So it's going to be 2 times 1/4 minus 2.
1/2 minus 2 is negative.
That's going to be a positive over a negative.
It's a negative.
It's a negative number. I don't even care what it is. If it's negative, is it going to be the green option that I have up here? Or is it going to be the blue option that I have up here? Did I hear somebody say green?
No.
Wenzel, you looked away. Did you say green or did I mishear? Okay, cool. It has to be blue because it's negative. And I don't even care how negative it is. We're just sketching it. That look and the smile afterward makes me think that maybe I'm not going crazy, but that's okay. Check it out. This is what this section does. Now, I'm going to make a claim to you guys, and I want you to answer the how do I do this? I know 100% what's happening. I know whether it needs to be up here, and I just put that there randomly because we were talking about testing a point out there. I know, me personally, 100% whether it's this option up here, and I'll draw them right now. You don't draw both of them. It's either A or B. Do you know which one it is? Or rather, how do I know which one it is? And I'm going to make a claim. I'll tell you, it's A.
Oh.
Yeah,
Why?
because it said it doesn't go below the thing twice.
What do you mean it doesn't go below the thing twice?
What's that? The asymptote
So I'm not really concerned about it just going below the asymptote, but you're on the right track.
between the
If it were going to touch the x-axis again, would I have found another x-intercept?
Yeah.
But did we?
No.
So the fact that it can't touch the x-axis again means that B doesn't even have a chance. It can't happen like that.
So it's A.
It has to be A. And upon the other side, without even plotting points, and you could confirm f of 2 is 4 over 6, which is 2/3, which is like right here. It's above it. But I don't have to do all that because I can use the fact that our x-intercepts don't exist there. That's what this side does. What does the other side do?
It does the
Over
same,
here. Why can't it do this?
because there's no other x-intercept.
Yeah, these are the only x-intercepts. The only option is for it to stick up here. And now we have this graph completed, sketched, only finding one additional point and never having to do any long division. Okay, I need your guys' honest feedback stuff. Declan, whether you did the assignment or not is not the focus here. Do we need more practice with these graphs?
Yeah.
Should we do one more together?
Yeah.
Okay. Do you want to take a really quick walk to the science lab?
Yeah.
Very briefly.
Yeah.
Okay, if the fisheries class is in there, we will not go in.
They're just with
Think
this.
so.
I don't know. I'm hopeful there's some chalk in there, but we'll see. It's going to be like 30 seconds, just so you know. All right. These problems. Let's do one more together, and let's see if we can't find a weird one. That was number 17, right?
yeah.
Yeah.
Let's do 16 together.
I feel like 19 was harder.
Yeah, I don't think so.
Oh no.
It's definitely not harder.
Wait, 16?
What about 18, right?
Let's look at 16. I know you didn't do it, but if we're spending more time because we need practice, we're going to practice. So let's do it. Okay, if you haven't done the assignment yet, you might have got lucky because I'm just going to take an assignment tomorrow, but I want you to do 16. Everybody is going to do 16. I know it wasn't on last night's assignment. I added problems to last night's assignment for first hour, just so you know, or I just gave them a different assignment. But let's check. Did anybody finish it completely?
Yeah, I did.
I will talk with you independently because I want to make a big announcement, but we'll talk. All right, 16. Let's look at F. Whoa. It's not a bad thing, just so you know. Okay, real quickly, we're a few minutes into the lesson real quick. Here's the deal. You cannot sabotage any of your classmates. But my favorite color is green, and my favorite number is 7. If the Bagleys make a comment to this statement and they tell me that my favorite color is green and my favorite number is 7, on Monday, when they're back in class with us, I will give them candy. If they don't say anything, you guys will get candy. But you can't go and tell them, nope, there's no video today, we didn't do anything, don't watch it. Don't sabotage their learning.
Oh,
They can sabotage themselves if they're not going to watch it.
Watching the video.
Yeah, so you guys might get candy. Don't encourage them to. Don't encourage them not to. I will encourage them to. I always do. But I want there to be more than just getting a 0 on a homework as a punishment for
So
it.
now you could ask them if they watch the video in class.
Oh, yeah. Oh, yeah.
Say yeah, and
yep.
ask them what your favorite color is. And
Yep.
you'll know.
100%.
They just
Cool.
lie to your face.
Yep. All right.
It's sad.
I'm not really just getting them to catch them in a lie. I just want them to face the no candy punishment if they do not do this. Anyway, here we go. I mean, the real punishment will probably be on the test if they don't do the practice stuff, right? Here we are. We're going to graph this one. And we're going to do it the same way. We're not going to do the long division stuff. We're just going to jump right in. Do we need to do it together? Do you want to do it together? Do you want to try a couple minutes on your own? What do you...
Together. Okay.
Okay, so we're going to go the same way. I don't know why I always go in the same order. I'll do scratch work stuff over here, and then I'll erase it to graph it at the end. So let's see. What do you want to find first?
The numerator, or like factor it.
Let's factor stuff first. Okay, here's my question for you. How does 6x squared factor?
3x and 3x.
But that'd be 9x squared.
Oh, 2. Doesn't.
It doesn't. You don't have to. Because there's nothing, right? It's just a 6 times x times x. If it's a binomial, we're going to try. So the top doesn't, and I'm fine with that. What about the bottom? 3x squared plus 1. How does this factor? It's a binomial. Do you know the square root of the first term?
No.
Do you know the square root of the second term?
Yes.
Is it a difference?
No.
Ooh. I mean, if we were looking for the zeros, we'd have to use the formula. Or we could solve it a different way. Does it factor?
Division.
If I can't break it down nicely, because I can't find those numbers, I don't think it factors. It doesn't. We don't have a way to factor the sum of squares unless we jump into the imaginary numbers. Do you know about the imaginary numbers? Do you know what this is? I still can't tell for sure because I agree with you. Do you know that this is this? Okay, so we'll hit that as well. Luckily we avoid that for the most part moving forward. But all right, so it doesn't factor. Bummer. That's okay. Well, we still need to find the vertical asymptotes, the horizontal asymptotes, and I'm going to call these the x-intercepts instead of the roots again. Which one do you guys want to start with?
Vertical.
All right. So, hey, I need the scratch work anyway. The vertical asymptote happens when the denominator is equal to what?
0.
0. Now, I can't factor it to solve it, but it doesn't mean I don't have a way to solve it. Kian, we could use the quadratic formula if you wanted. I don't want to, but we could. There's only one thing with x here, right? Let's just isolate it. How do I make it only x's on the left?
Minus
I'm going to do two things. I subtract 1, and then I'll divide by 3. And now I have x squared, but I want x. So I'll take the square root, and it's at this point that we should recognize something about it. The square root of a negative number. Is it a real number?
It's an I.
It's an I. Are we ever going to find a place on our real numbers when we're graphing x and y to put an I value?
No.
No,
So it'd be 0.
none of them. It's not 0. There are 0 of them. This is a weird example. There aren't any asymptotes. There's no real numbers that make me divide by 0. The only place I divide by 0 is with an I in it, and that won't show up on our graph. Okay, so there aren't any, and I'm going to change that from white to blue for continuity's sake. All right, so bummer, maybe. I don't know. It's kind of nice. How do we find the horizontal asymptotes? What's the degree of the top and the degree of the bottom? And the ratio of their leading coefficients will give me y equals? Not 1. 6 over 3 gives me 2. So there is a horizontal asymptote, and it's at 2. How do I find the x-intercepts of my the entire function?
Find the zeros.
Of what?
The
Not the denominator. And Kian, we're going to do it back and forth really quick. We're going to say the same thing like 4 times, okay? The zeros of the denominator give me the vertical asymptotes. Good. What do the zeros of the denominator give me? How do I find vertical asymptotes? The zeros of which part? Good. So, for this, because we're not looking at asymptotes anymore, what makes a fraction 0? When the top is bottom, or what? That doesn't make sense. When the top is 0 and the bottom is 0. So Wenzel, can we ever divide by 0? No. We're going to blow up the world if we do that or something. I don't know. The top is what we get for the x-intercept. So you guys are going to help me real quick. I need to make it so 6x squared equals 0. What are the x's that I get? I'll divide by 6.
0 and 0 again.
Good. It's plus or minus 0, just the same way, which is a goofy thing to write, and I recognize that. The only reason I would ever actually write x equals 0 and 0 here is so that it's very clear that what happens. If it's an even multiplicity, what happened on the last one? I can see it on my screen even. So every time, every single even multiplicity, it'll touch the x-axis and turn around. Okay, what if it's odd? What happens then?
Odd, like,
And-
what do you mean odd?
So if this had only showed up one time, it wouldn't touch and turn. What would it do? It would cross it. Good. Okay. So with this information, we almost have enough to graph it. Now, just like before, we may have to make a decision and get one extra point to really decide on something, but we're going to figure it out. And maybe we will. We'll get a better picture.
We have to plug in number.
And let's see what number that'll be, though. Yeah, I agree with you. So I know that it has to go up to 2, because that's where my asymptote's going to live. And since I have to go up that far, weird, I'm just going to use 1 dash as 1 here on mine. So this is 5 on mine. And you guys can see the grid a lot better than I can for whatever reason. I'm going to put my only asymptote, which is what flavor this time?
2.
I'll take that. I was looking for horizontal, but I'll take that all the same. And I will use purple, because that's my kind of standard. Here's my horizontal asymptote at y equals 2. And now I can dash it. Cool. Okay. What point can I put on my
The origin.
the origin? Now, here's the weird part. Do you think it goes down or up?
Well, there's no x-intercept, so it doesn't matter, actually.
It does matter. Because what does it have to get close to? Which y value will it approach at the end? Let me rephrase that question. It's the same question. What's my horizontal asymptote? If I go downward, eventually I have to come back up, and I would have found a what?
X-intercept.
Yep, so it can't go downward. But there is still some confusion here. I know it goes up. Are you guys okay with that? Logically, we can all agree that that's there, or you're just agreeing with me because you think I know what I'm saying?
I know that it's there.
So my graph could leave one of two ways. I know it touches and turns. It could touch and turn down like this, or it could touch and turn up like this, right?
Would it not hit anything when it touches turns up?
Sorry?
It would have not touched the x-intercept when it goes up.
I mean, it still can, because watch. It touches and turns. So I can still do it. It has to do this, though, Jade, because if it went downward, to get over to this asymptote, would I have to cross the x-axis?
Yeah.
But do I ever cross the x-axis?
No.
No, only at 0. So it goes up, but we're not quite enough, because there's a few ways it can go up. Can it cross this in the middle area?
Yeah.
So I have two options. It either does something like this, and then settles back down, which is possible. Graphs exist that do this. You might not have ever seen them, but they do exist. Or it does something like this.
But we don't know, so we think.
But we could, if we wanted a really bad sketch, but we could find out. I think we can find out pretty quickly.
Plug in.
All I need to know is, if I pick a value really close, is it going to skyrocket up or is it going to stay below? So let's pick a point or two to just check.
1.
Let's try 1.
1.
Yeah, let's try when x equals 1 and see what f of x gives me. If I do f of 1, it's really easy to calculate. 6 times 1 is?
Is 6 over 3.
6, not
6
quite.
over 4.
6 over 4, which is?
2.
Try again.
Why 6 over 4?
Oh,
Because
and a
6
half.
times 1 squared is 6, over 3 times 1 squared is 3, plus 1.
1 and a half.
I get 6 over 4, or 3 over 2 is how it simplifies, which is 1.5. That is roughly, not roughly, that's right here. Could I check one more just to make sure it doesn't pop up and above? Yeah, let's check 2. If 2 just gets closer, but it's still underneath, then it probably stays underneath. Let's try f of 2 real quick, just to get a little clearer picture.
4 times 6.
4 times 6 gives me,
4.
and since this is already 4, what's 3 times 4?
12.
Plus 1.
So 13 over
Is this bigger than 2 or less than 2?
less than.
Barely less than 2.
So it doesn't go over.
So it looks like it'd be like here, right?
Yeah.
All of a sudden, I now know what this does. It doesn't seem for sure, at least, that it's not going to cross, which means I know it's going to come up and start getting close, and it's going to come up and start getting close. How good do you think our graph is?
Pretty good.
Let's compare really quick. 6x squared over 3x squared plus 1. Lost. There it is. Yes. Already forgot it. Somebody's going to have to read it to me in just a second. Y equals 6x squared over what?
Um,
3x squared plus 1?
Yeah.
oh wow.
That's pretty stinking good for not having to put a whole lot of effort into it. Would you guys agree?
Yes.
Is this better than picking a bunch of points still? Oh my gosh, so much better. Okay, here's the deal. If you did not finish the assignment last night, or if you did, what I'm going to do is to last night's assignment, I'm going to add 2 problems. And I'll talk with you guys, because we'll see what it is. You guys, I lied. I won't even talk with you. I want you to add to last night's assignment 27 and 30.
37 to 30.
Nope, just 27 and 30. Which means the entire assignment at this point is 10, 15, 17 through 23, 27, 1 second, 30 and 34. I'm sorry, Desi?
If
Why
16 is part of it, put 16.
Just keep it on there, because if you put it on there, just keep it. I'm good with that. Because 34 is also on last night's assignment. Wasn't it? Yeah. I've added these 2 problems. Cool. Awesome. We get a little time to work. I kind of have a headache today, so I'm going to put on some nice chill music to hopefully help alleviate that. But I'm not saying that because I don't want you to ask me questions or anything. We have 15 minutes to work on stuff. Work on stuff so that if you have questions, you can ask today while we're in class.